Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. Let's move further with the new chapter, which is termed as mensuration. You can also say this particular chapter as surface area volume of 3D objects. So there are many boards which will write down the title as mensuration, and there are many boards which will write down surface area volume of 3D objects. Children, this particular chapter is very easy. Only one thing is what we need to know is the formulas. There are various 3D objects is what we are going to study in this particular chapter. If I know the formulas of all those 3D objects which are there listed in our syllabus, then the chapter is very simple. Mind you, it's a formula oriented chapter with bit of logic applied, and you are through with the entire chapter. So let's start in understanding all the formulas of various figures. At times I'll make you understand how the formulas got derived. At times you have to by heart the formula. Most of the cases is what we will try to obtain, but in very few you have to by heart the formulas. That's what I urge my students, that this is what you should do, by hearting the formulas, whereby which if you can understand those formulas how we have got it, fair enough. Ultimately what you need to do is by heart the formulas. Let's start with the very first thing. The first one is rectangular parallelepiped, commonly known as cuboid. Cuboid is what you all are very much familiar with, but it is also termed as rectangular parallelepiped. That's the reason I have given you the actual name, rectangular parallelepiped or cuboid. So how this particular structure looks like, children? If you all have seen a brick, right? A brick is nothing but a structure of rectangular parallelepiped. A brick is nothing but a structure of rectangular parallelepiped. Or for that matter, any rectangular hall is again a structure of rectangular parallelepiped. Say for that matter, these are number of books which I have kept one above the other. When I have kept number of books one above the other, again what structure I am getting is nothing but a rectangular parallelepiped. Now children, what we need to learn in this is, if this is what a rectangular parallelepiped is, what parameters, what terms this particular figure has. This has length, this has breadth, and this has height. So a rectangular parallelepiped or a cuboid is a 3D object with length, breadth, and height. So let's see, this is what our figure is. We have a length, we have a breadth, and we have a height. Now before we proceed further, children, we would like to know how many faces does this rectangular parallelepiped has. So let's switch over to this composite structure which I have made it of various books. Children, when I say that this is a rectangular parallelepiped, it is made up of 6 faces. Let's count. 1, 2, 3, 4, 5, 6. How many? 1, 2, 3, 4, 5, 6. Total 6 faces. Now if you happen to look at each face, what can you see? What kind of geometrical figure can you see from this front face? Don't you think so? It's a rectangle. The face which appears to you is a rectangle. This is a rectangle. Exactly behind is also a rectangle. Children, now what kind of figure is this? This is also a rectangle. If this is a rectangle, this is also a rectangle. What is this, children? This is a rectangle. Even this is also a rectangle. Thus, how many faces we have? We have 6 faces, and each face happens to be a rectangle. Now, having understood that there are 6 faces, let's understand how many horizontal and how many vertical. If I say vertical, that is standing faces, also termed as lateral face. If I say vertical, that means standing faces, also termed as lateral faces. 1, 2, 3, 4. How many vertical faces do we have? 4. 1, 2, 3, and 4. How many horizontal faces do we have? 1, 2. How many horizontal we have? 1, 2. So together how many? 6. Let's refresh once again. In a rectangular parallelepiped or a cuboid, there are 6 faces, each face being a rectangle, 2 horizontal and 4 vertical. Right, children? Let's start with the formulas, how we obtain the formulas for all these. So the very first thing is what we need to know is area of base. The very first formula which we need to know is area of base. Now when I say area of base, What do you think so? What is a base? As we have just now seen, base is a rectangle. What according to you the area of top is? Again, it's a rectangle. So can I say area of base is equals to area of top? Area of base is equals to area of top, and that is nothing but length into breadth. Why? The base is nothing but a rectangle, so the area of base is length into breadth. Right, children? We move on to the second one. The second one is area of vertical face. Area of vertical face, which is also termed as lateral face at times. Area of vertical face, how did we get it? Let's try and understand. If you can make it, we'll understand how we got area of vertical face. Now children, I want you to assume something. This is nothing but a paper, children, right? Now I'm keeping this particular paper in front of you. I'm keeping this particular paper in front of you. So what can you see as a front view? What can you see as a front view? What you can see is mere a line. What you can see is mere a line, whereby which we are talking about vertical face, right? So what we see is mere a line. Now what I want you people to know is, if I start from here, come along here, here and here. Sir, why did you took this is okay, but why did you take this? Because even this and this will count for vertical face. Though as of now you are not able to see vertical face, but very soon you will be able to. Just understand what I'm trying to make you all. If I count from here, or if I start from here and come back here, what is this termed as? Is this termed as perimeter? When I start from here, go, come back, it is termed as perimeter. Now children, just visualize. I want your good amount of visualization. When I say right now, are you able to see any face? Answer is clear cut, no. But what if I pile 20 more papers? Do you think so the thickness will increase? Indeed. Say if I pile 200 papers, yes sir, the thickness is going to increase more. And what if I pile more than 200, say 500, 600 papers? Don't you think so the structure will be like this? So earlier we had only a line, but on piling the paper, that means just giving a height to it, what we got is nothing but a vertical face. In front of you children, this is nothing but a vertical face. This is also a vertical face. This is also one of them, and this is also one of them. I hope you managed to got it, right? We said from here to here is perimeter, and then we projected the height, and automatically the face which was not easily see area of vertical face. Why I told you all these things, children? For a simple reason. To make you all understand, the area of vertical face has a general formula. What is the general formula? I am just writing that general formula in box. Area of vertical face has a general formula: perimeter into height. Perimeter into height. What is the general formula, children? Area of vertical face is perimeter into height. Now comes, sir, what is the perimeter of rectangle? The perimeter of rectangle is twice L plus B. So we are still into this particular type, that is this particular area of vertical face. So perimeter is nothing but twice L plus B into height is nothing but H. So what is the general formula for area of vertical face? Area of vertical face, general formula is perimeter into height, but when we substitute the value, what answer do I get is twice L plus B into H. So what is the formula for area of vertical face? Area of vertical face is nothing but twice L plus B into H. Likewise, we move on to the total surface area. The total surface area henceforth will be termed as TSA from our side. The total surface area henceforth will be termed as TSA from our side. TSA is nothing but total surface area. Now children, when I say total surface area, what exactly we mean by saying that? Let's once again try and understand the structure. When I say total surface area, that means I have to count area of all faces. As we know now, how many faces did we had? 6 faces. Right children? So let's start one by one. Take all the 6 faces into account. Let's talk about 2 horizontal face. This one. Right? What is the area of the above one? Is it length into breadth? As we have discussed. What is the area of below? Length into breadth. So LB length into breadth, which is LB. This is also LB. So how many LB we have? 2 LB. How about this one? When I say this one, it is breadth into height. It's also a rectangle. So breadth into height. So this is BH. If this is BH, if this is BH, this is also BH. This is also BH. So how many LB did we get? We got 2 LB. How many BH did we got? We got 2 BH. Now the remaining two are this one and the behind one. L into H. L into H. So this is LH. This is also LH. How many LH children? 2 LH. How many faces we had? We had 6 faces. And now we have taken 6 faces as twice LB, twice BH, twice LH. When I say total means everything taken into account, total surface area is nothing but twice LB plus twice BH plus twice LH, 2 common LB plus BH plus LH, 2 common LB plus BH plus LH. I hope children, my students are getting all the formulas which we are trying to derive for you. Next thing what we are going to come across is the fourth one is what we are going to have is volume. What is the fourth one children we are going to study? The fourth one what we are going to study is volume. Volume, the general formula for volume is, mind you, the general formula for volume is area of base into height. Area of base into height. Now again, if you want, I can try to make you all understand. If you all can, I shall try to make you all understand how again this particular formula came into existence. Now you are aware that this is what we are taking from past couple of minutes. Now do not consider this as a paper children. I don't want you to consider it as a paper. If you are looking this paper like this, I just want you to consider this as a hollow loop. A hollow rectangular loop. So when I say hollow rectangular loop, there is a loop one, hollow one. So I just have a wire here. I have a wire here, here and here. Right? Please don't take it as something which is already filled. We are having a loop which is totally hollow. We can see in and around. When I say I have a hollow loop, if I place this hollow loop on the surface and try to pour water on it. Right? Sir, this doesn't sound good. When you try to pour water on a loop which is kept on the surface, the water is going to spill out because there is no thickness as such. So water is going to evenly spread. Rightly said so. This is what is going to happen. But now what if I do is that if I somehow manage to get such 50 loops and stick, you can say with any kind of adhesives, right? If I pile 50 loops one above the other, don't you think so that I'll be getting a tank? I'll be getting a tank. And if I have a surface attached to it, and now if I happen to pour water, don't you think so that I can easily fill water? So now where the water is going to get accumulate, it is going to be there on the surface. And when we said it is going to be there on the surface, and when I said that I erected one above the other, I gave a height to that loop, one above the other. And if I have a structure of 50 such loops, I'll be getting a rectangular tank. So area of base, my water will be here, and the water level will increase to the height. Are you getting me children? So what is the general formula for volume? The general formula for volume is area of base into height. The general formula for volume is area of base into height. Thus volume is nothing but area of base L into B into H. Area of base is nothing but L into B into H. Thus now we have 4 formulas in front of us. We have 4 formulas in front of us. Let's highlight all those formulas. Area of base is equals to area of top, which is L into B. Area of vertical face, which is nothing but perimeter into height. That's the general formula, mind you. Thus it is nothing but twice L plus B into H. Next is total surface area. As we have said, total surface area means sum up of all the areas of all the faces, twice LB plus BH plus LH. And finally when I say volume is nothing but L into B into H. The general formula for volume is area of base into height. I hope my children have understood what we have done for the first figure. Now whatever we have done for the first figure children, absolutely on the same lines we are going to deal with the other. We are going to deal with the other. But now, according to me, since you have understood this, these are going to be very easy for you people to understand. Right? I hope I have tried my best to make you understand how the formulas got derived. Let's move on to cube. Now, you must have played with the dice, right? What is a die? Die is nothing but a sort of cube. Now, what is the difference between a cuboid and cube? At times, people take it the same. No, children. Cuboid is different and cube is different. Then what is the difference between cube and cuboid? The difference between cube and cuboid is nothing but the length. In cuboid, we had length, breadth, and height. Right? It's a 3D object. Even cube is also 3D object. My breadth is also L and my height is also L. My length is L, my breadth is L, my height is also L. So it's a dimension, it's a 3-dimension object. It's a 3-dimension object with all the measurements equal, with all the measurements same. Now, when I have a 3-dimensional object with all the measurements same, that is length, breadth and height are equal, which we have termed as L, what change will happen in the figure? Each face in a rectangular parallelepiped, mind you, each face in a rectangular parallelepiped was a rectangle. Here, each face is going to be square. There are many who already answered before I answered. There are many who already answered before I said. So, the major difference between a cuboid and a cube is, here we have length, breadth and height. Here we have length, length and length. All happens to be same. Each face was a rectangle. Each face is nothing but a square. So, on these lines only, mind you, we are following absolutely the same lines. So, on these lines is what we are going to write down. What? First, area of base. What is area of base, children? Don't you think so that area of base and area of top is the same? So, area of base is equals to area of top. And since base is a square and the area of square is side square, so over here the area is going to be L square. Area of base is equals to area of top. Area of base is side square. Therefore, area of base is equals to area of top, which is L square. With this said and done, let's move with the second part. Area of vertical face. Area of vertical face. Area of vertical face. How much is that, children? Now, each face happens to be square. How many vertical faces we have? 6. Like what we had in cuboid, here also the faces are going to be 6. 2 horizontal, 4 vertical. Right? There is only change in the dimension. There is no change in the faces, number of faces. So when I say area of vertical face, each face happens to be a square and area of each square is L square. So what according to you, area of 4 faces, 4 vertical faces happens to be 4L square. So area of vertical face is nothing but 4L square. What is area of vertical face? Area of vertical face is nothing but 4L square. Now those who wanted to learn that, sir, you gave a general formula, can you please make us understand how this will be working here? As you said, general formula is perimeter into height. Surely, children, I can make you understand that also. Let me say, though with a different marker, that base, perimeter. So what is perimeter of the base? So what is perimeter of square? Perimeter of square is 4 into side. So perimeter of square is 4 into side into height. Perimeter into height. So what is height over here? Length only. Thus 4 into L will give me 4L square. 4 into L will give me 4L square. So once again I proved it with this particular formula, the general formula. Area of base is area of top, which is L square. Area of vertical face 4L square. Now children, on the same lines, let's proceed further with the third one, total surface area. So what is total surface area? Total surface area. Now, when I say total surface area, once again I'm talking about all the faces. So how many faces we have? 6. Each face happens to be square. Area of square is L square. So area, a total surface area of 6 faces is nothing but 6L square. Is nothing but 6L square. Are you getting me, children? Though we don't have a general formula, but I can derive the same thing from the above one. From the above formula what we had for parallelepiped. L into B. But over here, B and L is the same. So L into L, L square. B into H. We don't have B into H, but we have L into L. So L into L, L square. L into H, but we have H itself as L. So L into L, L square. L square plus L square plus L square. 3L square into 2, 6L square. We could have understood it that way also. So children, understanding is more important. At times we mug up also. But if we understand it and, mug up, I think so it will make a good amount of difference. We move on further with. So this is nothing but our total surface area. Let me highlight this. So this is our total surface area, 6L square. On the same lines, we would like to go with the volume also. On the same lines, we would like to go with the volume. So what is the volume? Volume is nothing but, let's start with the same one, area of base into height. So what is area of base? It's a square. So area of base is L square into height, which is again L, which is L cube, which is nothing but L cube. So volume is area of base into height. So volume for a cube is nothing but L cube. So these are the four formulas of cube. Let's refresh it once again. For rectangular parallelepiped, area of base is equals to area of top, which is L into B. Area of vertical face, which is perimeter into height, general formula, which is twice L plus B into H. The total surface area is twice LB plus BH plus LH. The volume happens to be L into B into H. When it comes to cube, area of base is equals to area of top, which is L square. Area of vertical face, which is 4L square. Total surface area is 6L square, and volume happens to be L cube. Children, this is what we have to memorize after understanding this. Let's proceed further with a cylinder. Now how cylinder will be and how cylinder looks like. Now you are aware, I can say this is also a cylinder. This is nothing but a cylindrical pen, right? If this paper is held in this form, if I just make it in this way, also this is termed as a cylinder. This is nothing but a cylinder. Now children, what is the difference do we see? What is the difference do we see from these two figures and the cylinder which we are going to study now? What is the difference? Children, all the faces what we had in cuboid and cube were flat faces. Nowhere we had any curved face. All the faces were flat, mind you. And here what is going to happen, when I hold and when I make the cylinder like this, I do have flat face, but it is the base one and the top one which is flat. But then I have this one as a curved surface area. This is nothing but the curved surface area. We had flat faces. We have flat face, mind you. But here we have something called as curved surface area. What is the difference between this and this? Here we had area of vertical face. Instead of vertical face, we'll be having a curved surface area. Otherwise, this also has a top, and this has a top. Instead of vertical face, we'll be having curved surface. That's the major difference. Let's proceed further, children. Now, when I say that this is what the cylinder is, now you are aware. What are the two components of cylinder? The two components, parameters of cylinder are nothing but radius of base and perpendicular height. Radius of base and perpendicular height. Now children, what according to you, if I hold like this, sir, I can see you and you can see me. But what exactly is this? This is nothing but a circle. So can I say area of base is equals to area of top, which is nothing but circle. So area of base is equals to area of top, which is nothing but circle. We start off with writing on the same lines. On the same lines is what we'll be writing as. First, area of base is equals to area of top, and each being circle, the formula for circle is pi r square. The area of circle is pi r square, and by this time you are aware that we are supposed to take value of pi as 22 by 7 or 3.14, whatever is stated in our question. So what is area of base? Area of base is equals to area of top, which is pi r square. With this said and done, the next which was coming was area of vertical face. So next which is coming over here, as we stated just some time back, a minute back, here it will be curved surface area. Curved surface area. Now, there are many who say that, sir, here you stated perimeter into height. Is the same thing going to work out when we have this curved surface area? Is the same general formula going to get worked out? Indeed, yes. Indeed, yes. Now, I want you to recollect, as around 7-8 minutes or more than that has been passed out, 10 minutes has been passed out. How did I made you all understand this? I said that you need to have a rectangular loop, right? So on the same lines, what I want over here, area of curved surface, how to understand. I'm having this particular bangle in front of me. I'm just keeping this in front of you. What exactly are you able to see? Are you able to see a good amount of face? No, I doubt you'll be able to see. Yes, you can say a line, and those who can visualize a 3D one, you will say it's a curve. Nothing more than that. So starting from here, if I have to come here, once again, what is that termed as? That is termed as circumference. In circular object or circular figure, we call it a circumference. That's the other word for perimeter. Circumference is the other word for perimeter. Perimeter is a word we use for flat objects, right? And circumference is the word we use for curved objects. So this is nothing but my perimeter, which is circumference. What if I do a bangle above the bangle above the bangle? Don't you think so that I'll get this kind of structure? I will get this kind of structure. And when I have this kind of structure, the face which was not seen, now is it seen? The face which was earlier not seen, is it seen now? Certainly yes. So what did I do so? Perimeter, and then projected the height. So our formula still remains the same. What is it? Perimeter into height. Our formula still remains the same. It is perimeter into height. So what is the general formula? Circumference into height. I will not write down the general formula, mind you. I'll write down the direct answer. Perimeter, which is 2 pi r. Perimeter, which is 2 pi r into height. 2 pi rh. 2 pi rh. So what is curved surface area? Curved surface area is 2 pi rh. What is area of base equals to area of top? Pi r square. What is the third formula which we had seen? Total surface area. Here also there will be total surface area. Here also there will be total surface area. Henceforth, the curved surface area will be termed as CSA, and the total surface area, as I have already said, will be termed as TSA. So the total surface area, when I say total surface area, total means everything. When I say total means everything, let's once again make this cylinder so that you can understand. Is this area of base? Is this area of base? Is this area of top? This is area of base, which is circle. Area of top, which is circle. And then do I have curved surface area? Right, children? So what is total? Area of base plus area of top plus curved surface area. So let's write down that. What is total surface area? Total surface area is nothing but area of base plus area of base plus area of top plus area of top plus curved surface area, as I'll be writing as CSA. So let's jot down what is total surface area. Total surface area TSA is nothing but area of base pi r square, area of top pi r square, curved surface area 2 pi RH, pi r square plus pi r square, 2 pi r square, 2 pi r square plus 2 pi RH. Answer is 2 pi r common. 2 pi r common. What is left over here is r plus what is left over here is h. Thus total surface area. Thus total surface area is nothing but 2 pi r r plus h. So total surface area 2 pi r r plus h. Curved surface area 2 pi r h. area of base pi r square. Area of base pi r square. Last one, children, last one, what is remaining is volume. What answer did we had? The general formula, area of base into height. Again, that is what we are going to apply here also. So volume, when I say volume, volume is nothing but, again, area of base into height. Let's take once again this bangle. Let's take once again this particular bangle. Now, if I have to say that I would like to fill water on this, if this being kept on a surface, if I would like to fill some kind of water in this, will water get accumulated or filled? Answer is no. Whatever could be the thickness of the bangle, till that the water will be there, and thereafter it is going to spill. But what if I keep one above the other? If I keep one above the other, and then don't you think so that I have projected a height? I have projected a height and a circular tank is formed. So now I can easily pour water into it. So area of base into height. So what answer now, children, you should have? What answer you should have is area of base, which is pi r square, into height. So the general answer we have is pi r square h. The general answer is pi r square h. Volume is pi r square h. I hope my children are understanding. Right, next figure, what we are going to see is nothing but for cone. Now, before proceeding with the actual formulas, we need to understand the three terms. What are the three terms? L stands for slant height, H stands for perpendicular height, R is nothing but the radius. So, L is nothing but slant height, R is nothing but radius, and H is nothing but perpendicular height. H is nothing but perpendicular height. Now, children, before we proceed, as I stated, we need to know the relation between L, R and H. Now, if I focus on this particular right angle triangle so formed, in my diagram, there is a right angle triangle so formed. With the help of Pythagoras, can I get L square is equals to R square plus H square? So that's the relation between, relation between L, R and H. What is the relation, children? L square is equals to R square plus H square. What is the relation we got? L square is equals to R square plus H square. Let's start with the first one. What is the first one? The first one is area of base, children. What is area of base? In a cone, the base is nothing but circle. Therefore, area of base is pi r square. In cone, area of base is pi r square. Next thing is what we need to know is the curved surface area. The curved surface area is nothing but, if you want you can write down total, the curved surface area is pi r l. What is the curved surface area, children? Pi r l. Now we move on to the third part. The third part is total surface area. When I say total surface area, what did I said earlier? When I say total means everything. Now what are the two components existing over here? It's area of base and the curved surface area. So what is total surface area going to be? Area of base plus the curved surface area. I'll just write down as CSA. What is area of base, children? Pi r square. What is curved surface area? Pi r l. Now if I happen to say pi r common, I'm left with r plus l. So total surface area is nothing but pi r plus l. We just say, and we just give a momentary pause when we happen to say it verbally. Total surface area is pi r plus l. This momentary pause indicates this opening and closing of brackets, children. Next we move on to is volume. Now volume is given by the formula 1 by 3 pi r square h. What is the volume? Formula for volume? Formula for volume is 1 by 3 pi r square h. What is the formula for volume, children? The formula for volume is 1 by 3 pi r square h. Though not conceptually, I reiterate, not conceptually, but somehow logically, I can make you understand, somehow logically. Now children, this is nothing but a cylinder. This is nothing but a cylinder, right children? This is nothing but a cylinder. Now within this cylinder, if I try to 1, 2 and 3, logically, I said logically, there will be 3 cones within a cylinder. So what is the volume of one cone? 1/3 of the cylinder. And since cylinder was pi r square h, volume of cone, each cone will be 1 by 3 pi r square h. Because each cone within a cylinder will be 1/3 of the total. Are you getting me? Though I said it's logical. So volume of each cylinder, each cone will be 1/3 of the cylinder. Let's summarize the above two. We said for cylinder, right circular cylinder, actually I should say right circular cylinder, area of base is equals to area of top, which is pi r square. The curved surface area is 2 pi r h. Total surface area is, summing up all, 2 pi r plus h. Volume is pi r square h. For cone, before we proceed with the formula, we need to know the relation between L, R and h. L square is equals to r square plus h square is the relation between them. We went with area of base pi r square, curved surface area pi r l, total surface area pi r plus l. After summing both the areas, finally volume 1/3 pi r square h. We move on to the next one, which is nothing but a sphere. For sphere, everybody must have played with ball, right? A lemon is nothing but a kind of sphere. Ball is a structure of sphere, one can say so. So children, let's understand the formulas for sphere also. Now children, you must be wondering that why sir has not written area of base is equals to area of top. In all the 3 cases is what I have written, area of base is equals to area of top. But why not here? Top is a point and point doesn't have an area. Top is a point doesn't have an area. On the same lines, when I say for sphere, the component over here is radius, I need to say what is area of base. What is area of base? Area, this is area, mind you. What is area of base? Area of base is nothing but 0. Why the area of base is 0? When you keep a ball on the surface, you might think that, sir, ball takes a good amount of area depending upon the size of the ball. If you take a smaller plastic ball, it will take a smaller area. But if you keep a football, it will take good amount of area. In spite of that, why do you say area of answer is? It is being stated, or it is being considered as, that whenever we have a circle placed on the surface, the surface acts as tangent to it. The surface acts as tangent to it. And what do you mean by tangent? My children are aware. Tangent is a line touching the circle at one and only one distinct point. A line touching the circle at one and only one distinct point. Thus, we have to consider that the base of the sphere is nothing but a mere point which is touching the surface at one point. That's the reason area of base is 0. That's the reason area of base is 0. Now, unlike the others, you won't find any flat face. Sir, all the faces were flat. Sir, we had a flat face, but we have a curved face also. Sir, we had a flat face, but we had a curved face also. Here, you are not going to find any kind of flat face. Wherever you see, wherever you check, we have curved face only. So this time, we have curved surface area equals to total surface area. Why total surface area and curved surface area are the same? Because there is no flat surface. So I'm writing in short, curved surface area is equals to total surface area. The curved surface area is equals to total surface area, which is 4 pi r square. What is curved surface area equals to total surface area? Curved surface area is equals to total surface area is 4 pi r square. So let me highlight this. Area of base is 0. Let me highlight this. Curved surface area is total surface area, which is 4 pi r square. The fourth one, which is our third one, since CSA, TSA happens to be the same, here the third one is nothing but the volume. Now volume is what my children has to remember it. The volume of the sphere is 4 by 3 pi r cube. Volume is 4 by 3 pi r cube, right? Having understood what's a sphere, what if I divide the sphere exactly from between? What I get is nothing but a hemisphere. What if I divide the sphere exactly in between? Then what I get is nothing but a structure which is called as a hemisphere. Now children, if you have a lemon, you slice it exactly from between. Don't you think so that it gets divided into two hemispherical ball? Two semi-spherical, or hemispherical is the right word we use, hemispherical ball. The moment I slice it from the between, now I have a flat surface in the form of base. Visualize, you have a lemon, you are slicing it from between, you place it on the floor. When you place it on the floor, right, this is floor, area of circle, that's what it is. So after slicing it from between, we have flat surface. Earlier we never had any flat surface in sphere, but in hemisphere we do have a flat surface and we do have a curved surface also. In sphere we did not have, but in hemisphere after slicing we obtain. So let's start. What is the first one? Area of base. We don't have top over here, so area of base. Now my children must have understood what is area of base, which is area of circle. Area of base is nothing but area of circle, right? Hemisphere, the base will be circle. So area of base is area of circle, which is pi r square. Area of base is equals to area of circle, which is pi r square. Next thing is, what is the curved surface area? The curved surface area. Let's understand from this, picture will be more clear. When I say curved surface area, am I talking from this point, coming back to this point? Starting from here, go rotate round the circle, come back to the same point, and the answer is 4 pi r square. So what if I have to start from here and take exactly a half round, not a full round? What is the answer going to be? Curved surface area. Here it was 4 pi r square, here it shall be 2 pi r square. As simple as that. As simple as that. Here TSA will come into play. TSA, total surface area, is what? Area of base plus CSA. What is area of base? 2 pi r square. Well, pi r square. I'm sorry. Area of base is pi r square. So what is area of base? Pi r square plus curved surface area 2 pi r square. Sum up together 3 pi r square. Sum up together 3 pi r square. The total surface area is 3 pi r square. Finally, the volume. Finally, the volume. If the volume of entire is 4 by 3, what will be half? Half into 4 by 3. Hemisphere is half of sphere. As we said, hemisphere, half of sphere. 4 by 3 pi r cube into half will be getting 2 by 3 pi r cube. What we shall be getting? We shall be getting 2 by 3 pi r cube. So what is total surface area? The total surface area is 3 pi r square. What is volume? Volume is 2 by 3 pi r cube. I hope my children have understood. Let's refresh sphere and hemisphere. Area of base of sphere. First we are talking about sphere. Area of base 0. Curved surface area equals to total surface area 4 pi r square. Volume 4 by 3 pi r cube. For hemisphere, area of base pi r square. Curved surface area 2 pi r square. Total surface area, after summing up, we get 3 pi r square. Volume 2 by 3 pi r cube. I hope my children have understood. Now, I would like to summarize the entire one. So right from here, you're going to, let's summarize. Along with me, you should also. Start off with first. I hope you are able to see. First, for a rectangular parallelepiped or cuboid, area of base is equal to area of top, L into B. Area of vertical face, twice L plus B into H. Total surface area, twice LB plus BH plus LH. Volume, L into B into H. For cube, area of base is area of top, L square. Area of vertical face is 4L square. Total surface area, 6L square. Volume, L cube. For cylinder, area of base is equal to area of top, pi r square. Curved surface area, 2 pi r h. Total surface area, 2 pi r plus h. Volume, pi r square h. Cone, very first thing is the relation between L, R and H. L square is equal to R square plus H square. Area of base, pi r square. Curved surface area, pi r L. Total surface area, pi r plus L. Volume, 1 by 3 pi r square h. Sphere, area of base, 0. Curved surface area equals to total surface area, 4 pi r square. Volume, 4 by 3 pi r cube. Hemisphere, r square. Curved surface area, 2 pi r square. Total surface area, 3 pi r square. Volume, 2 by 3 pi r cube. If you know, children, all these, you are almost done with mensuration. That is surface area volume of 3D objects. Thereafter, mere substitution of the values, calculation, we are done.